All right, in this opener number 14, it appears that I'm just trying to find the equivalent of the square root of two numbers multiplied together. So is it that I add them, or do I subtract them? Do I just multiply the individual square roots? Do I divide them? Is it none of those? Well, one way to figure these rules out is by examples. So let's start writing some examples. And we're going to create 6 examples that to either prove that's true or that the others are not true. So we're just going to consider 6 cases to see what it tells us. And when I'm doing square roots, I like to pick perfect squares because that makes it easier for me to solve. So let's try a case where A is 9 and B is 16. So in case A, is the square root of 9 times 16 the same as the square root of 9 plus the square root of 16? That's my case A. Is that true? Well, let's compute what this is just so we can use this. And then we'll try different numbers to make sure that it's not just some weird thing that goes on with just these particular numbers. Let's see. Let's just make it so you can see this. So the square root of 9 times 16 tells me the answer is 12. 12. Okay, so I'm looking for 12. So this is 12. Is 12 the same as square root of 9 plus square root of 16? Well, the square root of 9 is 3 because 3 times 3 is 9. Square root of 16 is 4. So is this true? Nope. So if it's not true for the one you pick, then it's probably not true for anything. Okay, but sometimes when you find one that is true, it's not always true for everything. So this one, no, not A. Not A. Okay, so let's try B with the same numbers. When we get one that works, maybe we try a few more to make sure it works for a lot of different cases. So is 12 the same as square root of 9 minus square root of 16? Well, that's 3 minus 4, and that is not true either. Right? Negative 1 is not 12. So that's another case not true. What about if I multiply them? Is the square root of 9 times the square root of 16 the same as 12? Square root of 9 is 3. 4 is 3 times 4, 12. Definitely. So C seems to work. But maybe it's just something special with those numbers. So let's pick some more square roots we know. Let's see. What if A were 1, because 1 times 1 is 1, and B were, I don't know, 81, which is 9 times 9. Is the square root of 1 times 81 the same as the square root of 1 times the square root of 81? In fact, it is. The square root of 81 is just 9, and this is 1 times 9. So that works. And maybe let's just pick one more number, and then we'll test our last example to see if there's another thing. So I don't know, let's pick A is 25 and B is 100. And try that. So this is square root of 25 times 100. Is that the same as square root of 25 times square root of 100? Is it the same as 5 times 10 or 50? Well, this is the square root of 2500, which when we take the square root of it, we get 50. So in fact, it is true. So C is a solution. And if we try D, well, if we go back to our original, look at that, we eventually find that 12, right? Is 12 the same as square root of 3 divided by square root of 9 divided by square root of 16, which is the same as 3 over 4? Well, no, that is not true. So C is it. When you're multiplying, the product of square roots is the same as the square root of the product of the numbers. And this is going to become very useful when we start to simplify our square roots.